Hello, we're Capstone Group 2 for Mechanical Engineering. Our project is the active control of flow separation in the turbofan engine intake. You may be asking, what is flow separation? Here, let me show you. Here we have a block highlighted in green. As we can see, as the flow goes around the edge, it separates from the surface of the block. This region, highlighted in blue, is called the separation region. First, let's imagine a diffuser, since a diffuser is a lot like the intake of a turbofan engine. As the area increases, it creates a region of high pressure. This causes a force on the fluid that pushes it backwards. At low speeds, this will cause a region of recirculation, preventing the fluid from moving forward. In a turbofan engine, where there are multiple compressor stages at the beginning, this is a big problem as we can get a large negative pressure gradient. This can cause something called compressor surge, where the flow goes back and forth trying to reach the combustor. This is a big problem as it causes gas to build up in the combustor. It all ignites at the same time and can cause an explosion. So how do we prevent this phenomena? We can use blowing or suction actuation systems. Both of these systems force the flow to reattach. However, before we can actuate the system, we have to detect flow separation. This is often the most complex part of flow control. And this is our wind tunnel. At the intake, we have a honeycomb. This straightens the flow. Here we have 2 layers of mesh. These break up the turbulence and provide us an even, uniform flow for our test section. In our test section, there are 2 things to note. This is the smoke wire. When we layer the smoke wire with beads of glycerol and heat it up, it creates a stream of smoke that allows us to visualize flow separation. Here, we have our pylon and nacelle. This allows us to test flow conditions in a realistic situation. And this is our sensor setup. Here, we have 6 sensors set up to an op-amp and an Arduino board. This provides us a signal so that we can detect flow separation in an empirical fashion. From there, the Arduino collects the signal and sends it back to our computer. The MATLAB code on our computer interprets the signal from our sensors. After that, it sends a signal to the servos if it detects flow separation. If it does detect flow separation, the servos then actuate and cause blowing or suction to happen into the cell, correcting flow separation. Hello, we're Capstone Group 2.
Restart.
Okay.